Okay, now that we have our eigenvalues, let's get our eigenvectors that go with those. And we do this by taking an eigenvalue and plugging it back into our a minus lambda I form. So let's work through that. Let's take lambda equal to 2 to start. So that means that we want a minus 2 times I to be equal to 0. And plugging that in and setting it up, we have minus 1, minus 2, 1, 2, and then we'll go ahead and throw in our zeros on the other side here. Again, the a minus 2i form coming from our above form here. So we'll take, in this first example, 2 and plug it in for lambda to get this matrix here. So now let's go ahead and solve this. And I see I've got a correction to make. This should be a 2. And if we try and solve out this system, it's pretty clear that the second row is a linear combination of the first one. So this reduces immediately. And this is kind of the expectation when we're working through these, that we would just get one row as a multiple of the other. And I've gone ahead and multiplied through by a -1 on that top row just to make it look a little nicer. So at this point, we're done. We just need to extract out the vector from this. And we would do this in our normal fashion, write it out as an equation again. So I get x1 plus 2x2 equals 0. And we see that x2 is equal to itself. And we can put this into vector form. x1 is going to be equal to minus 2x2. And again, x2 equals itself. And that would imply then the vector x would have to be equal to minus 2, 1 times x2. So this vector here is our eigenvector. And I leave it up to you to solve through for what you get when you take lambda equal 3 and find the associated eigenvector that goes with that eigenvalue.